Okay, so we'll continue again with our unit number 1, which is Introduction to Engineering Risk and Uncertainty and Risk Methods. Engineering risk analysis and definition and overview we'll study first. So, in everyday conversation, the word risk is often used to mean the likelihood or probability of something that is usually negative happening. So, in our everyday life or in general, the word risk is used to mean the likelihood or probability of something negative which is happening. So, when we talk about the risk of having an accident while driving, of contracting heart disease or cancer, or of being struck by lightning in a thunderstorm. So, this may be the negative happenings when it comes to the word risk. For example, like accident while driving, contracting heart disease or cancer, or of being struck by lightning in a thunderstorm. These risks are considered by, for example, insurance companies using statistical data as the basis of assessment. So, in the context of engineering structures, when it comes to engineering, risk is often used in a more restrictive sense to express both the probability, that is, the likelihood of an occurrence such as the failure of the structure, and the degree of consequences or results that are arising from it, example, lives that has been lost. So, the association of probability with consequences may be purely qualitative and judgmental. So, using terms like high, medium, and low, and this may be useful in assessing relative risk. Where the probability of occurrence and the consequences can be quantified, then risk is formally defined as the product, that is, risk is equal to probability of occurrence into consequences arising from the occurrence. So, from engineering point of view, risk is used for a more in a more restrictive way, and it is used to express the probability and occurrence. Probability meaning likelihood, and occurrence, that is an event or something that has already occurred. Here the example cited is the failure of a structure, since we are talking about engineering structures, and also about the degree of consequences arising from it, that is the result of the consequences that is been arose due to the occurrence. That is, for example, when a structure fails, then what happens, what is the consequence? The result is the lives are lost. So the association, that is the connection of probability with results, that is consequences, it is purely qualitative and judgmental. Qualitative and judgmental, for we use terms like high, medium, and low when we refer to qualitative and judgmental. And this qualitative and judgmental probability with consequences are useful in assessing or determining relative risk, that is, basic risk. So, where the probability of occurrence and the consequences can be quantified. When you can quantify the results and also the occurrences that took place, then risk is defined as the product, which is that is defined here. Risk is equal to probability of occurrence into consequences arising from occurrence. In simple, risk is equal to occurrence into results. That is the outcome of the occurrence. Okay. Next, buildings, bridges, chemical plants, and pipelines are usually built and maintained in accordance with standards and codes of practice that aim to achieve a certain target reliability, which is probability of not failing. So we all know that when bridges, buildings, plants, thermal plants, pipelines, when these are usually built, these structures are built or even maintained by following certain standards and building codes or practices. Why these standards and building codes are there? Because it aims to achieve target reliability. This target of reliability means the chances or the probability of the structure not failing. But failure of, say, a pipeline will have very different consequences for persons if it occurs in a crowded city where people may be injured rather than in the unpopulated desert. So, here the case for the example cited is if a pipeline is constructed in a crowded city, then definitely if there is a failure of pipeline, many lives will be lost because it is constructed in a crowded city. But if the same pipeline is constructed in an unpopulated desert, and if the failure of pipeline occurs, then no injuries will be occurred since it is an unpopulated desert. So no matter how likely the event may be, failure, if it occurs, the event, no matter how likely it may be, failures may occur and certain risks still exist. There are only chances, or there are only probability of not failing. So the risk to persons associated with a city-based pipeline is therefore higher. So when city-based pipeline, people who are connected or associated or who live in a city-based pipeline environment or surrounding, they have a higher risk of losing their lives or having even an accident, assuming that the two pipelines are designed and operate in the same way. But the pipeline, which I have said, is if it is installed in a crowded area also, it will be designed and operate in the same way. Similarly, if it is installed in an unpopulated desert also, it will be designed and operated in the same way. So risk reduction can involve reducing either the probability of failure of a structure or the consequences of failure. So risk reduction, it involves or it incorporates what? Reducing the chances or probability of failure of a structure or the results of failure, or both, or it can refer to both. So reduction of the probability of failure can be achieved by various engineering measures. So it is achieved by various engineering measures such as decreasing the operating pressure of a pipeline. The pressure that is applied on the pipeline is decreased. Then controlling the number and weight of vehicles on a bridge. The number and weight of vehicles that goes over the bridge is controlled. Providing redundant load paths in the structure so that the failure of one component will not lead to the failure of the entire structure. So providing or giving or building a redundant, that is a dummy load path in the structure, so that when the failure occurs in one component, the other entire structure does not fail even if the failure occurs in one component. So reduction of the consequences of failure, on the other hand, could involve a number of actions unrelated to the reliability of the structure. So when reduction of the consequences of failure involves a number of actions, and these actions are not related to the reliability of the structure. For example, excluding as many people as possible from the area of risk. That is, example, building a fence around a chemical plant, carrying out pressure testing of equipment outside normal working hours. Number two, building a blast wall between pressure vessels so that failure of one does not lead to the failure of an adjacent vessel. Number three, training of staff, and where necessary, members of the local population in emergency procedures. So even though it may be understandable from the context of discussion what is meant by the different words, it is necessary in the context of engineering decision making to be precise in the understanding of risks. In simple or in general terms, we may understand the term risk, but we should try to understand it more in the context of engineering decision making. So risk is to be understood as the expected consequences associated with a given activity. So how is risk understood? Risk can be understood as the expected results or consequences which is associated with a given activity. This activity can be a construction operation or a decommissioning of a power plant. Next, introduction to risk-based decision making. So as outlined in the foregoing chapter in the previous discussions, engineering facilities such as bridges, power plants, dams, and offshore platforms are all intended to benefit some way or the other to the quality of life of the individuals or society. So therefore, whenever such facilities are planned, it is a prerequisite that the benefit of the facility can be proven considering all phases of the life of the facility, that is, including design, manufacture, construction, operation, and eventually decommissioning. So, any engineering facility that is like such as bridges, power plants, dams, and offshore, if it is constructed, why it is constructed, definitely it is intended for the benefit some way or the other to the quality of life, as a contribution to the quality of life of the individuals of a society. So therefore, when such facilities are planned or constructed, certain phases of the life of the facilities are considered. So these certain facilities or phases which are considered includes design, manufacture, construction, operation, and eventually also decommissioning. So if this is not the case, clearly the facility should not be. So if these factors, that is design, manufacture, construction, operation, decommissioning, are not included, or these phases are not included, then the facility should not be even established or planned. So on a societal level, a beneficial engineering facility is normally understood as being economically efficient in serving a general purpose. So on a societal level, or in general in a society, a beneficial engineering facility is understood as which is being economically very efficient or good and also serves the definite purpose. Then fulfilling given requirements in regard to the safety of the personnel directly involved, which are indirectly exposed, that is the safety of the personnel who are laborers and all who are involved in the construction process, fulfilling given requirements for the adverse effects of the facility of the environment. So based on these requirements, it is realized that the ultimate task of the engineer, sorry, okay. Okay. So based on these requirements, it is realized that the ultimate task of an engineer is to make decisions or to provide the decision basis for others such that it may be ensured that engineering facilities are established in such a way that they provide the largest possible benefit and so that it is not proven to benefit then so that if not proven to benefit, they are not realized at all. So, based on these three requirements that is mentioned, the ultimate task of any engineer is basically to make proper decisions. These decisions should be based mainly focusing on the possible largest benefit of the facility. And if those facility does not benefit, then then it is not benefited. That should also be not realized by anyone. Like even if it is not benefited, it should not be realized by anyone. And if it is benefited also, then also it is a very good thing. So first example is feasibility of hydraulic power plant. So consider as an example the decision problem of exploitation of hydraulic power. So a hydraulic power plant project involves construction of a water reservoir in a mountain valley is planned. In a mountain valley, a hydraulic power plant project or construction of water reservoir is being planned. The benefit of the hydraulic power plant is for simplicity assumed associated only with the monetary income from selling electricity to consumers. So the benefit of this hydraulic power plant in simple words means selling electricity to the consumers and getting benefit from that. So the decision problem thus simplifies to comparing the cost of establishing, operating, and eventually decommissioning the hydraulic power plant with the incomes to be expected during the service or the life of a plant. Okay, so the decision problem that will, in simple words, means to compare the cost of establishing, operating, and decommissioning the hydraulic power plant with the incomes to be expected during with the income that you will receive during the service life of the power plant. So, in addition, it must, of course, be ensured that the safety of the person involved in the construction and operation of the plant and the safety of third person, that is the individuals or the societies general, is satisfactory. So the third point that is to be considered here is the safety of the laborers or personnel involved in the construction and the operation of the plant, and also the safety of the individuals of the society who will live nearby. So those are considered as third persons. So different solutions for establishing the power plant may be considered, and their efficiency can be measured in terms of the expected income relative to the cost of establishing the power plant. Efficiency of the power plant may be considered or determined or measured in terms of the expected income or consumer income related to the cost of establishing the entire power plant. So, however, a number of factors are important for the evaluation of the income and the cost of establishing the power plant. Many factors are important for evaluation of income and establishing power plant. These are example, the period of time where the plant will be operating and produce electricity and the capacity of the power plant in terms of kilowatts. So moreover, the future income from selling electricity will depend on the availability of water, which depends on the future snow and rainfall. So the future income of this power plant will depend on selling electricity and also on the availability of water, and this availability of water depends on the future prediction of snow and rainfall. But also the market situation may change and competing energy resources such as thermal and solar power may cause a reduction of the market price on electricity in general. So the other effects, disadvantages that this power plant may have is like the ongoing or competing energy resources that are available, that is thermal or solar power plant. And this may cause a reduction in the market or consumer price of electricity. So in addition, the different possible solutions for establishing the power plant will have different costs and different implications on the safety of the personnel. Obviously, the more capacity of the power plant, that is the higher the dam, the larger the construction cost will be. In simple words, if the dam is higher, the construction cost will also be higher. But also the potential flooding consequence of dam failure will be larger. So when the dam is higher and the construction is larger or the construction cost is larger, definitely the potential, the flooding occurrences will be, or flooding results, that is the consequence or result of dam failure will also be more, the probability will be more. And in that case, more people will be injured or they may die. This is the town for figure 1.5, water reservoir dam for exploitation of hydraulic power. Dams with water reservoir, dams and town. Next, the safety of the people in a town downstream of the reservoir will also be influenced by the load carrying capacity of the dam structure relative to the pressure loading due to the water level of the reservoir. Safety of the people of the town, it depends on the downstream of the reservoir, and so this downstream of the reservoir will influence the safety of the people in this town. And how it can be done by the load carrying capacity of the dam structure, which is related to the pressure loading. This pressure loading is due to the water level in the reservoir. Due to this, if it increases, this load, this dam may not be able to bear the load. So load carrying capacity is very important. The strength of the dam structure depends in turn on the material characteristics of the dam structure and the properties of the soil and rock on which it is founded. So this strength of the dam depends on the dam structure and properties of soil and rock on which it is founded. So as these properties are subject to uncertainty of various sources, as shall be seen, the load carrying capacity relative to the loading may be expressed in terms of probability that the loading will exceed the load carrying capacity. So finally, the environmental impact of the power plant will depend on the water level in the reservoir. From this portion, these three paragraphs are left. This will continue in our next class as the meeting will end in within 5 minutes. You can give her attendance now in the chat box. Thank you. So thank you all for this class. We'll meet in our next class and continue with the water reservoir exploitation of hydraulic power plant. Thank you.